All right. So yeah, it's okay. Just now moving on. These are all the functional groups that we have. After this, we're gonna hop on directly to, okay, I'm gonna skip deliberately isomerism for this masterclass because isomerism, we can do it some other time as well. Okay, it's gonna consume too much of our time. And it's also not required for the rest of the organic chemistry lessons. Okay, so you're gonna skip isomerism for now. We will do this later with you, Rafi. Okay, I'll do it with you later.
Yep. Okay.
I've already done it with Amal. All right, now
Yeah.
after isomerism, we're going to directly hop on to alkanes now, and we're going to do all the reactions that alkanes particularly show. So if you're ready, let's start. Ready?
Yes.
Yes.
Okay, guys. So what is the general formula of alkanes? CnH2n plus 2. CnH2n plus 2 is the general formula of alkanes, meaning if you put in the integer of n as 1 or 2 or 3 or 4, you'll keep generating more and more formulas, more and more compounds of the alkane homologous series. Okay, so this is gonna, if when the value of n is 1, it's gonna become CH4, correct? And one carbon alkane is called methane. Does that make sense?
Yes.
Okay, what is one carbon called? It's called meth. And because it's an alkane, now the suffix of alkane is ane, right? Ane. That's why the name ends with an ane. Understood? So there's a prefix and there's a suffix to the naming. The prefix is meth and the suffix is ane. Understood?
Yes.
Now prefixes will keep on changing as the number of carbon atoms increase. If you have 2 carbon atoms, then the formula is going to become C2H6 based on this general formula, and the name would become eth. 2 carbon atoms are called eth, and hence the suffix ane will be added to ethane, and so on. Then you have C3H8, which is propane basically. Prop stands for 3 carbons, so ane. Then after propane, we have 4 carbons. What are 4 carbons called? Any idea, guys?
Butane. Butane.
Bute. 4 carbons stands for bute. Okay, and ane because it's an alkane. All right, what about 5 carbons? Come on, we have to name this up to 10 carbons. How about 5 carbons?
Pentane.
Pent.
Pentane.
5 stands for pen, and hence pentane. All right, six carbons. Keep going, guys, quickly. 6 carbons.
Hexane.
Hexane, correct. 7 carbons. 7 carbons.
Heptane. Heptane.
Heptane. 8 carbons. Rafi, what is 8 called? Let him answer. What is 8 called? What is 8 called?
Eight
Oct.
carbons.
Oct. Okay?
Octane.
Octane. And you can remember it this way. 8, 9, and 10 are very easy to remember because October, November, December is what you have to remember. Oct, no, dec. October, November, December. 9 carbons is called nonane, and 10 carbon is called decane. Understood?
Yes.
C9H, 20, and C10H, 22. These are all the alkanes that we have, and that's all you need to know. Meaning these are all the prefixes you guys are required. Okay. The same prefixes will be repeated with alkenes. The same prefixes will be repeated with alcohol, with carboxylic acids as well. But what would be the difference, Amal? What do you think would be the difference?
Between what? Sorry.
Sorry.
I wasn't listening. Sorry. What did you say?
Okay. So are you listening now?
Yes. Sorry.
Yeah. Okay. So the question is that what would be the difference when the homologous series changes? Like apart from alkane, if we have alkenes, if we have carboxylic acids.
You add a functional group.
Yeah, and because of that, the suffix is gonna stay the same or change.
It's gonna change.
The suffix will change, but what about the prefix?
It will stay the same.
Prefix stays the same. All right. Correct. Good job. Okay, so this is all about alkanes. After alkanes, okay, let's do all the naming of alkanes quickly as well. Okay, how will you exactly name an alkane? So basically, we have methane CH4. That's it. Nothing else required. Nothing fancy needed. But if you have longer alkanes like CH4, C4H8 basically, this is butane, right? This is easy to name because it's a straight chain structure. Now there are 2 types of naming that we have in our syllabus that we have to know. All right, one is called IUPAC naming, and the other one is called common naming. The common naming does not have any logic. It's just based on some very trivial logic, non-logical stuff. So it's just called trivial naming as well. And it doesn't really have any logic to it. It's just a name that you need to memorize. And IUPAC naming does have logic. It does have a proper set of rules. And IUPAC naming can be used to name any compound that's there. IUPAC stands for International Union of Pure and Applied Chemistry. Understood? So they actually give names to all the different compounds that are there. So, Rafi, any guesses about this? Any prior knowledge?
I don't have any prior knowledge on this.
Okay, no worries. Let's get started with this, and inshallah, at the end of this discussion, hopefully you'll understand what this is. So let's talk about IUPAC naming first. So basically, what is this compound? What do you think? Is this an alkane? It doesn't have a functional group. Rafi. This is the displayed. This is the displayed formula. The displayed formula of C4H10. If you count all the hydrogens, there are 10, right?
Right.
And if you count all the carbons, there are 4. So we have C4H10 in here. Understood?
Okay. Yes, understood.
All right. Now this C4H10 is called, what is it called?
C4H10.
Called butane. Okay?
Right.
It's called butane. Now this butane, because it's a straight chain structure, it's all you need to know. It's just called butane. That's it, nothing else. But if you change the structure a bit, okay, meaning if you put a branch in here, instead of the hydrogen, if you put a CH3 over here, the name is going to change. So let's see how the name is going to change. So basically, if you have 3 carbons in a straight chain and 1 carbon as a branch, okay, then how will you exactly name the structure? So to name the structure, you first need to know what the longest continuous carbon chain is. So first of all, you need to understand what continuity means in terms of naming. So if you look at these 3 carbon atoms, they are in a straight line, correct?
Yes.
1, 2, 3.
Yes.
Yes, Rafi?
Yes.
So being in a straight line means they are continuous. Now, even if they are, even if you have a carbon atom up here and you're going straight, it's still continuous. Okay, but the moment you need to override, return back, and come down like this, that's where the continuity breaks. Okay, you do not. This continuity break of continuity is not accepted. You need to have only continuous chains. Okay, so either you can have a chain that goes like this, or you can have a separate chain that goes like this. Okay, both of these have 3 carbons. Understood?
Yes.
This one is 1, 2, 3. And this one is 1, 2, 3 again. So how many continuous chains do we have in total in this compound?
There's 2 chains.
How many?
2, because there's one on the bottom, and there's one.
This is 1, and then this is the second one, right? But there's a third one as well. Remember? Coming down, going forward. This one? This line that I made?
Oh, yes. Yeah, yes.
So we have 3 continuous chains.
3 chains.
Also have to remember it like this. For example, if you have many carbon atoms going like this, if they're coming down like this and they're going like this, are they continuous? Are they all continuous? Yes, they are. Because you are still going in a straight line. Okay? If you have carbon atoms going like this, coming down, and then going straight, still continuous. Understood? But if you have a carbon atom that goes out of the line, then now this is where the continuity breaks, because the moment you go down here, you cannot return. Remember, you cannot overwrite on the line. Okay? Meaning you have the urge to come back like this, but this is where the break occurs. You cannot have break. If there is a break, then that means it's a separate chain now. Understood?
Yes, understood.
Okay. Now, out of these 3, which one do you think is the longest continuous chain? Let's start counting them. 1, 2, 3, 4, 5, 6, then 7, 8, 9. This one has 9 carbons.
Okay. And this one,
excuse me. And if we go down, 7, 8, this one has 8 carbons. 10. And if we go like this, let's count this as 1, 2. Then we have the third one. Which one is the third one? and the fourth, 5, and 6. We have 3 chains, one with 9 carbons, other one with 8 carbons, and other one with 6 carbons. Understood?
Yes.
Okay. Now that you understand the meaning of continuous chain, always remember the fact that you need to identify the longest continuous carbon chain. That's rule number 1. Okay. What's rule number 1? Identify
To
the
identify the longest continuous carbon
longest
chain.
continuous carbon chain. Once you have done that, then you need to, the second rule is to identify all the branches. Identify all branches
Okay.
which are attached. Now, branches mean any group that is outside the continuous chain. So, for example, in this particular case, for example, if we are considering one chain, well, all chains are equal in length. They're all 3 carbon long. But let's say if we are talking about only this chain, then this carbon atom becomes a branch because it is outside the chain. Understood? Now, because it is outside the chain, we have to name that as a separate branch while we are writing down the name. Okay? Now, the naming is going to be a bit different, in which you have to identify the position and the type of all the different branches that are there in the compound. Now, for example, if you have a compound that looks like this, CH3, CH2, CH2, then CH, and then CH3. And there is a carbon atom attached to this CH3. Now tell me, which what are the number of carbon atoms in the longest continuous carbon chain? Do you see the longest continuous carbon chain? This can be the longest chain,
Yes, it
or
can.
this can be the longest chain, right?
The one that goes straight across.
We have two continuous chains here. This can be a continuous chain, or this can be a continuous chain. Now both of them, are they equal in length?
Yes,
Count the
they are.
carbon atoms.
1. They both have 5 carbon
They
atoms.
both are equal, right? So we can take any one of them if you want. I'm going to take the straight one, but you can take the other one as well. As okay, no problem. Now
Okay.
you've chosen it. Then the next point is to number all the carbon atoms that you have. Now you can number it from both the sides. Now, which numbering have to be accepted? Let's see. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Now the numbering on the right gives the branch a second position, and the numbering from the left gives it the 5th position, right? We always choose that numbering which gives the branch the lowest possible number. Understood?
Yes.
The numbering that gives the branch a lowest possible number will be accepted. And now this branch, whenever you have one carbon atom attached to as a branch, it's called because one carbon means meth, right? Meth. And this is called the methyl branch or the methyl branch. Okay, however you want to pronounce it. So the name is going to become, now it's on the second position, right? So 2-methyl. Now the reason why I put a dash is to separate the numbers from the alphabets. 2-methyl. And then how many carbon atoms do we have in the longest chain?
5.
So this is 4 and this is 5. Yeah, we have 5 carbons. So 5 carbon alkane is called pentane. So 2-methyl pentane will become the name of this particular compound. Understood?
Okay. Yes.
Easy?
Yes.
Amal, all good?
Yeah, all good.
All right. Now, what if you have multiple branches attached to the same chain? Now, for example, you have a compound that looks like this, has 2 methyl groups on this position. Now, what to do? What's the first step, Rafi? Identify what?
Identify all the continuous carbon
The
chains.
longest continuous carbon chain, right? Then,
Yes,
what's
the
the second
longest.
step? Number it. From what side should I number? From the right, from the left?
Start from the left.
From the left, right? Because we need to give the branches the smallest possible number.
Right.
Now the branches get the second position. So what do you think would the name become? We have 2 methyl groups.
The name.
Can you try naming it? Because it's on the second carbon, the name is gonna become 2, 2. Okay, because both of them are on the second carbon and we have exactly identical groups. So we have to write
Okay.
down the two repeated twice. 2 comma 2 dash. Then we are going to write it as dimethyl. Okay, because we have two methyl groups. Dimethyl. And then because we have a total of 4 carbons, so we're going to call it butane. Okay, 2,2-dimethyl butane. Understood?
Yes, understood.
All right. Now, next, what if we have multiple functional groups and they're non-identical? Okay, so for example, we have an iodine dash here, we have a methyl group attached over here, we have a chlorine group attached over here, we have a bromine attached over here, we have a iodine attached over here as well, for example. Now, this is a compound that we have to name. Now, what side do you think we are gonna number it from? And have you identified the longest continuous chain already? Right?
Yes,
This is the
yes,
longest chain. What side do
yes.
we number it from?
The left side.
Why left side? Why not right?
The left side because
Yeah, keep going, keep going. You're saying it correctly.
I know it's left side, but I'm trying to remember what the
Because
reason
we need
was.
to provide the functional groups a lower possible number, right?
Okay, okay. It's left to provide the
So this is
functional
1, this
groups.
is 2, this is 3, then this is 4, this is 5, this is 6. So we have a
Right,
total of 6 carbon atoms. Now we have so many different functional groups attached, right? Now let's
right.
identify all the functional groups that we have. We have CH3, what is this called? This is called methyl, right? We have bromine, iodine, and chlorine. Now, all the halogens that we have, the halogens, when they are named as branches, they are called halo. Meaning bromine is called bromo, chlorine will be called chloro, and iodine will be called iodo. Understood?
Yes, understood.
So we need to start numbering them, but now the naming is going to be such that we have to do the naming alphabetically in alphabetical order. So which one will be named first? Bromine will be named first because B comes before all of them. So the name becomes 3-bromo, all right, with its
All
position,
right.
okay? The name with the position. Then again put a dash because dash is always used to separate the number from the alphabets. 3-bromo, then again a dash. Then after bromine, chlorine comes, right? So we have a 3-chloro. Then again, after chlorine, which number comes first? Which alphabet comes first, iodine or methyl? What do you guys think? Amal,
Yes. It'll be 1, 2 iodo.
1, comma 2 dash diiodo. Remember
Oh
2
yes,
iodine?
diiodo. Yes. 2
Okay,
diiodo.
diiodo. What else after that?
Dash hexane.
Did you forget the methyl? You forgot the methyl, Amal.
The metal.
2-methyl, right?
Yeah.
Then we have hexane.
Hexane. Okay.
So all we did was just identify the longest chain and wrote down all the branches in alphabetical order with their numbers. Okay, it's not difficult at all.
Okay.
Even though the name looks so big and scary, but it's not. It's just writing down the functional groups in alphabetical order with their positions. Okay, Rafi?
Okay.
Rafi,
Rafi.
all good? Hello. I'm muted, I think. No, you're unmuted. Okay, Rafi? Rafi, can you hear me? Hello? I can't hear you.
Mm,
Can you rejoin, please?
Yes. Something.
Rafi, can you hear me? Hello?
Yes, I can.
Yeah. Okay, so did you understand this part of the name?
Could you explain? I mean, it's a little confusing. I'm a little confused
Listen, all you need to
on the
do is
naming.
just write down all the functional groups in alphabetical order, and that's it. Okay?
Okay. Okay.
So all the functional groups that we have are methyl group, the branches basically. We have methyl, we have bromo, bromine is bromo, chlorine is chloro, iodine is iodo. Okay? The
Okay.
name is you numbered it from the left side. Now we are gonna name it alphabetically. So we have bromo on the third position. So 3 dash bromo. Then again chloro on the third position as well. So 3 dash chloro. Then we have 2 iodines, but on 1 and 2, right? So dash
Right.
1 comma 2 dash diiodo because there are 2 iodines, right?
Right.
And
Right.
then again put a dash and write down methyl because M comes after B, C, and I. So 2 dash methyl, and then finally the straight chain has 6 carbons, so hexane. Understood?
Okay.
It's just
Yes.
alphabetical order with its numbering.
Yep. Okay.
Did you understand how this name
I did.
came?
Yes, I did.
All right. So I'm going to give you practice name now. Try naming it quickly, okay? Kindly name it. Yes, guys,
Is
both of you. Write down the name, and then send me a picture of your name quickly. Both of you. You guys have 1 minute. Because this is very fresh, so I'm gonna help you out with the name, Rafe. You already know what
yes.
iodine is called, you know what bromine is called, you know what methyl is called, right? You
Right.
already know the names, so you just have to write down the names with the positions. Come on, guys, you can have 1 minute. The time starts now. Write it down and send me a picture.
Where do I send the picture?
Send me on WhatsApp.
WhatsApp? Okay.
1 second. I'm just getting a different pen.
Sorry?
I'm getting a different pen. 1 second.
It's okay, just send it. Send it.
Can I just send the name?
Are you saying something, Rafi?
Could I just send the name? Because
Yeah, you send it?
I'm sending. I'm writing it down.
Okay, okay.
I sent the picture.
It's correct, Amal.
Okay.
Rafi, it's correct, but you forgot the hyphens in 2 places.
Oh.
A hyphen
Okay.
after bromo and a hyphen after iodo.
Okay.
But the names are correct, yes. So you both got it correct. Well done. So we're done with the naming. Okay. We're done with the naming. IUPAC naming. Now we're going to do the common naming quickly. Common naming is also known as the trivial naming, and there's not much to it. We're going to just quickly do it. All right. So basically, if you have a methyl group attached on the second last carbon, then it's called, what is it called, guys? A methyl group attached on the second last carbon. Remember, it's not the second carbon, it's the second last carbon, okay? Methyl group on the second last carbon is called iso. And in this case, you don't just count the number of carbon atoms in a straight chain, you count the total number of carbon atoms that you have. So You have 5 carbons, so this is called isopentane. Understood?
Yes.
Yes.
What if you have two methyl groups attached to the second last carbon? Like this, then it becomes neo. It's called neo, and total number of carbon atoms are 6 now, right? Neohexane. That's how you're gonna name it.
Okay.
Okay. What if you have something like this attached to OH? Now, OH is called alcohol, right? So for common naming, now this is only common naming, okay? There's a methyl group on the second carbon, second last carbon.
Yes.
This is
Yes.
called isopentyl alcohol. Isopropyl alcohol, sorry. Then what if you have a tertiary butyl group attached over here? Something like this. This is called a tertiary butyl alcohol. Why tertiary? Because this carbon atom to which the OH is attached is directly attached to how many carbons?
3.
3 carbon atoms, right? So we call it tertiary butyl alcohol. Now, if you have an alkane in straight chain only, something like this, then what is it called in common naming? So it's the same prefix and suffix naming, but the only difference is that because it's a straight chain, so we just add this N in front of it. This is called N-butane. That's it. Nothing else. Okay?
Okay.
So with this, the trivial naming is completed for all the alkanes. Next, we have to do reactions of alkanes. Okay? If you guys are ready, we can do this reactions now.
Okay.
Reactions of alkanes. Alkanes mainly show only one specific type of reaction, but there are actually 3 types that we have to know. Alkanes can show combustion, free radical substitution, and cracking. Okay, the combustion, do you guys know what combustion is?
Yes.
Free radical substitution?
Yes.
This is the major one, substitution. And then the third one is called cracking. Combustion is when something burns in excess supply of oxygen. Combustion also has 2 types. We have complete combustion and we have incomplete combustion. Complete is when there is burning in excess oxygen. Incomplete is when there is burning in limited oxygen. Okay, when it burns in excess oxygen, you're going to get only 2 products, carbon dioxide and water. But when you burn in limited oxygen, you get carbon monoxide and other products as well, which are not really important. Okay.
Okay.
Yep. Okay.
All right. Then cracking. What does cracking mean? Cracking means the breakdown of bigger alkanes into smaller alkanes. Breakdown of larger alkanes into smaller alkanes. Using extreme temperature and pressure or catalysts. Usually the temperature that is used over here is around 600 to 900 degrees Celsius, depending on the different types of cracking that is there. But cracking is not there in detail, so we won't be studying it in detail. That's it. This is all that we are needed. Now, free radical substitution, which is the major reaction that alkanes show, and the mechanism is required. We've already done this, Amal. So this
Yes.
is a recap for you, and I expect you to remember all the information that we have studied already. Okay? Free radical substitution. But for you, Rafa, it's new, so it's okay. Let's learn it together. Free radical substitution. Now, any guesses what this is? Okay, so what was free radical substitution, Amal?
It's when
What is a radical?
It's like when there's an open.
What is a radical? A species with an unpaired electron, remember?
Yeah, it's an unpaired electron.
Yeah, a species with an unpaired electron.
So if the reaction,
This is a radical, and it's called substitution because alkanes, as you guys know, are saturated. So they cannot add in more atoms. They can only replace existing atoms with new atoms. Only replacements can occur. Nothing else is possible. Okay.
so free,
Free radical
so
is the name of the radical that is formed over here. Now we need to know the name of the entire mechanism and the type of reaction that is involved over here. So let's say we have CH4, which is methane. When it reacts with chlorine in presence of UV light, only then can this happen. Okay. It can be chlorine, it can be bromine, it can be halogens. One of the halogens is there, needs to be there. And so the one of the hydrogens is replaced with a chlorine, and that hydrogen just goes and attaches to the other chlorine atom that is there. This is the overall reaction that takes place over here. If you just saw this over here, Rafi, you can see
yeah.
that the hydrogen is being replaced with a chlorine, right?
Right.
Okay, now there are 3 steps of this mechanism that you need to know, including the name of the steps as well. The first step is called initiation. Now, initiation means that the chlorine molecule, now this is the very initiating step, the very starting step. Now, the sunlight that you have is going to come in direct contact with the chlorine molecule, and it's going to break the chlorine bond, chlorine bond, producing chlorine radicals or chlorine atoms. Now, these are 2 chlorine atoms that have been produced. The molecule has been broken. The chlorine radicals are basically chlorine atoms which do not have complete outer electrons, so they are highly unstable. Now, anything in nature wants to exist in the most stable state. Chlorine radicals are highly unstable, so they want to stabilize themselves. What they do is they go and attack methane molecule that is out there enjoying its life. But the chlorine radical needs to stabilize itself. So it's going to attack the methane molecule. Even though methane is a highly stable molecule, it's highly unreactive, but chlorine is way more reactive than that. It's a lot more reactive. So it's going to quickly grab a hydrogen away from methane and robbing it from one hydrogen, as a result of which the methane will only be left with a methyl free radical state. It will be left with an unpaired electron and HCl will be formed. The chlorine would have stabilized itself. Now, a methyl radical has formed. Now, this methyl radical is also a radical, right? It has an unpaired electron, so it's also highly unstable. So what it's going to do, it's going to attack a chlorine molecule that is there enjoying its life. It's going to go attack it, and it's going to rob this chlorine molecule from with a chlorine atom. So it's going to form CH3Cl. It's going to take away a chlorine atom from the new molecule and form another chlorine radical. Now, you can see that in propagation step, the chlorine free radical has been regenerated. Because of this, this reaction is actually considered a chain reaction. An entire chain starts off from here. The chlorine radical is going to go attack another methane molecule, which in turn is going to produce more methyl radicals, which are in turn going to produce more chlorine radicals, which will keep on attacking again and again. So an entire chain begins because of this chlorine radical being generated in the propagation step. We don't need to show all the other steps. We just need to show these 2 steps, and that's it. After this, we have termination, which is the ending reaction. In termination, at least 3 steps need to be shown. Now, in termination, 2 chlorine radicals can recombine to form a chlorine molecule. Okay. A chlorine radical can combine with a chlorine radical to form a chlorine molecule, or a methyl radical can combine with a chlorine radical to form a CH3Cl, the major product. And then in very small quantities, in very trace amounts, 2 methyl radicals can also recombine to form a new compound, CH3CH3. This is a 2-carbon compound. This is the ethane. But this is produced in trace amounts, and you are asked on your exam to identify the name of the compound that is produced in trace amount. Okay, the trace amount compound is ethane. Okay.
Yep. Okay.
So, for example, if methane was the major reactant in the beginning, the trace amount would have double the number of carbon atoms. So it has 2 carbon atoms. Now, for example, if we had ethane over here, then what would be the trace amount compound? How many carbon atoms would it have? Any guesses?
4.
4. Double the amount. Okay.
About
So with this entire termination step completes. Now, in our syllabus, we are also required to know the example of ethane, C2H6. This one, the one that I've written over here. If we have a reaction of ethane with chlorine in presence of UV light, we'll have a similar mechanism, exactly the same mechanism. Okay, but the only difference is that the steps and the reactants and products are going to be slightly different. We have C2H5Cl along with HCl. Okay, now again, we're going to begin with initiation step. In initiation, you know what to do. Again, you have to form the chlorine radicals, and then from there, propagation again. In propagation, the C2H6 will be attacked with a chlorine radical, which will form C2H5 free radical along with HCl. And then the C2H5 free radical is going to attack a chlorine molecule, which will reform the major product C2H5Cl along with HCl. Along with a chlorine radical. So in this case as well, the chlorine radical is regenerated. Okay. Once the chlorine radical is regenerated, that's it. You just stop there, and then the termination step. I'm just copying whatever I wrote on the left-hand side. I'm just copying it on the right side. Okay. So we have chlorine radical combining with chlorine radical to form chlorine molecule again. We have a C2H5 radical combining with a chlorine radical to form the major product C2H5Cl. And then we have a trace amount containing compound C2H5 radical combining with C2H5 radical again. What would be the formula of the trace amount compound, guys? Tell me.
C4H10.
H what?
10.
Just add them together.
10.
Oh, so
10.
10.
Okay. This is butane. And trace amounts. Okay, easy. With this, we actually
Yes.
finished off all the reactions of alkanes. Okay, this is all the free radical substitution required in the syllabus. All good, everything clear so far about alkanes? We are
Yes.
actually closing alkanes now. I'll just show you the syllabus real quick so that we can verify if anything is left. So we classified based on, well, we just didn't do the isomerism part, but we actually did quite a lot. So let's see how much we've done already. So organic chemistry done on structural basis. Okay, alkanes, alkenes, all of that stuff. Functional group done. Nomenclature of alkanes done. Free radical substitution done. Mechanism done. Okay, so we did all of this stuff. Now we're going to move on to the nomenclature of alkenes as the next step. Okay, this is what we have to do. Alkenes as the next. And then we are going to move on to benzene and then alkynes finally. And then alkyl halides, and we'll be done with the syllabus. At least the target of today. So I guess we can stop here now. Azan ho rahi hai, to namaz break le lete hain 10 minute ka. ठीक है, and after namaz inshallah we are going to continue. Namaz के बाद आप लोग screenshots ले लीजिए. ये अभी ले ले चले.